Now, I've been debating with a couple of boys out there on the YouTube channel, and they seem to think we're floating around on a big old ball spinning all around space. And I'm trying to explain to them if that were true, we'd see the sun not moving at a constant speed relative to us spinning around on that there globe that ain't real that they believe in. So I'm trying to explain it to them, but both boys don't seem too bright, because this so simple even a monkey can understand, but for some reason they still don't get it. So I'm gonna try to make it real simple so even like a monkey retard could understand it this time. So check it out. I'm gonna let the professor explain it because he's better talking than me. Take it away, Radvan. Alright, so look. If the earth is rotating and its rotation is what causes the effect of the sun rising and setting, okay? Um, you would have a slow moving sun relative to you in the morning as it rose. And I made the earth rotating the wrong way. I know it rotates the other way. A guy pointed that out. They're concerned with these little details, but they don't get the big picture. So yeah, it rotates that way. Okay. But the problem is you wouldn't have a sun or stars or heavenly bodies moving at a constant speed relative to us if the motion that is causing the movement is us rotating. And they can't seem to get this. So I'm trying to explain it this way. What you're really doing is you're traveling from point A to point B because you're coming around the bend, and at morning time we see the sun. We move this way and back around the bend. We don't see the sun anymore. So because we make this motion, the sun is moving. Looks like it's moving across the sky. Now, how do you get from point A to point B? So compare it to this. So let's say there's a guy watching a car go by. If it goes from point A to point B at a constant speed, he will observe the car traveling relative to him at a constant speed. But if he observes this car traveling at also a constant speed, and going from point A to point B, but not in a straight line, coming. So see the car, the way I drew it, it's coming at you. So it's coming around the bend, just like this motion. So this is like the earth, the rotation of the earth, coming around the bend, passing by you and going around you. I mean, come on, anyone that's seen a car race has seen this. I don't know if these guys really don't get it, or they're just pretending not to get it and being stubborn. Because if you get it, you gotta admit you lost the argument. I don't know which one's going on. I hope they're not wasting my time. It seemed like nice honest guys. I don't see how this is. We've seen this our whole life. You stand in the audience of a race car or horse races, or better with a car race, because you see the change happening quicker. As the cars come towards you, they're not moving much laterally as when they pass by and then go away, but they never change speeds. So now I got to go all the way and explain this. So the same thing would happen if you were in here looking at this guy. This positioning represents the sun. We're looking at the sun, but with a car, it could be like a person. It could be the sun too, But to try to make you understand, I chose to draw a person here. First, I had three suns, but maybe this will help understand a little better. And it doesn't matter how far away this person is or the sun is. It doesn't matter. The rule never changes. If you travel from point A to point B in a straight line at a constant speed, the observer will see that. And the key point is the person in the car will see this guy moving relative to him at a constant speed. Okay, same thing here. if the observer in this car is watching this person, or if this is the sun, we'll say it's a person, it could be the sun, and he's traveling at a constant speed from point A to point B, but in a circle, not in a straight line. As he comes forward, this guy's lateral motion relative to him won't change much. But as he comes across, he's going to pass him by quicker, and then he goes back around the bend. His lateral motion won't change much. And then if there was like a wall, let's say there was a wall here, he wouldn't see him anymore. So that would kind of represent like going behind the earth. But I think you get that. As we go around, we don't see the sun anymore. So there's a beginning point when you see it and when you don't see it anymore. Same with this. I could put like a wall. This could be like a wall, an actual wall, and the car just passes through here. So you don't see it. Pretend if this was a wall, you don't see this car on this side. It comes through at a constant speed and goes through this wall. So you would see it traveling. But here, if you put the wall between these arrows and the car comes around the bend, so there's a wall in between the circle, it comes around and moves this way in a 180-degree circle, you're not going to get constant speed of motion, moving at a constant speed as you would here. Hope you guys get it now, man. I mean, this is so easy, even a monkey can get it. Come on, boys.